In this example problem, we'll be looking at the speed of a thrown projectile as it goes through some curved path. Now, we're going to ask what's the slowest this object is ever moving. Now, we know something about how it's launched at the beginning. I'm going to say at least goes through the maximum of it and goes down to a lower height, sort of like this cartoony picture. So we know that the velocity of this ball is at a 45-degree angle and that the speed is 5 meters per second. Now, you could go through and kind of have a technical answer to this, but this is actually pretty easy to understand in terms of the just kind of the simple kinematics of it. So here's what I mean. Let's look at the initial velocity vector. It gets 5 meters per second. And there's some x component of it, and there's some y component of it as well. Now, there is no horizontal acceleration in free fall. So if you just use the Vx equals acceleration in the x direction times time plus the initial x velocity, acceleration is 0, so it's just that it always equals the original, whereas in the y, it'll be minus g t, because the acceleration is negative, and the y is negative g, negative 9.8 meters per second squared, plus the initial velocity and the y, and that'll go down over time, because t is going to be a positive number, g is a positive number, and t just gets bigger and bigger and bigger, so you keep adding a larger and larger negative number. So what that means is if later on, the velocity will look like this, and then like that, and like that, and like that, so that it always has exactly the same horizontal component, but the vertical component is changing. And now if you ask, what is the shortest of those arrows, the answer is going to be just this one right here. The one that has no vertical component, which is to say it's just when it's the entire magnitude is just the x component of the velocity. That's the smallest hypotenuse, effectively, is one that has no opposite length. So to find that, we just have to do some trig. We have a triangle, 5 meters per second. We want this distance right here. The right triangle, this is 45 degrees. And so the slowest speed is just going to be that 5 meters per second cosine of 45 degrees, because remember cosine is the adjacent over hypotenuse. And you plug that in, and you just get 3.54 meters per second. So the slowest it ever moves is about 3.5 meters per second. And this is not intended to be a particularly technical problem, but to help you visualize what happens to the velocity vector over time of a projectile. And again, the answer is the only thing that changes is the vertical component of it, not the horizontal component of it.